So in this video, we're going to apply summation formulas when we have a function to which we're applying them. So it says sum the 5 values of f of x equals 2x squared plus 1 for x equals 1, 2, 3, 4, and 5. And so really what we're doing is doing f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5, and then we would be plugging in the 1, the 2, the 3, the 4, the 5 into the function, crunching the number, and then adding it all up. What we want to do is avoid doing this. So we want to recognize that to take this sum, we could really write this in sigma notation. We could write this as this is the sum from I equal 1 to 5, from I equal 1 to 5 of f of I. And so if we do that, then we can go, this is the sum from I equal 1 to 5. And now everywhere we see x in our function right here, we replace that x with an I. So we're going to get 2 times I squared plus 1. And then we can use this summation formula and this summation formula at the same time to break this summation up into pieces. So I'm going to get a constant 2 times the sum from I equal 1 to 5 of I squared. So there's the 2I squared term, plus, using this summation formula, I get the sum from I equal 1 to 5 of 1. And this will be the first of 2 examples. The second example will play off of this but be a little bit more complicated. So in this case, now I'm ready to use the summation formulas. I have 2 times, I have a formula for the sum of the I squared terms right here. In this case, the upper bound of summation is 5, so we have the case where n is equal to 5. So we're going to replace, we're going to get 5 times 5 plus 1 is 6, times 2 times 5 is 10 plus 1 is 11, and then it's all going to be over 6, plus, now we have the sum of a constant term. So right here, where the sum of the constant term equals the upper bound of summation times the constant term. So if n is 5 and c is 1, we're going to get 1 times 5. And 6 will go into 6 once. So we can simplify. We have 2 times 5 times 1 times 11 is 110. Plus 1 times 5 is 5. So we get 115. So we'll look at a slightly more complicated example. We'll keep the same function, f of x equals 2x squared plus 1. But now we want to take the sum from x equals 1/10, 2/10, 3/10, 4/10, 5/10, 1/10 out to 5/10. So what I want to do is think about this flexibly. I want to think about this as being 1/10. This is 2/10. 0.3 is 3/10. 0.4 is 4/10. And 0.5 is 5/10. So I look at the denominator here is a constant 10, but the numerator is incrementing by 1. 1, 2, 3, 4, 5. So I really want to look at this as being I over 10, where I equals 1, 2, 3, 4, 5. So in summation notation, to take the sum of the function evaluated at each of these values, I'm going to take the sum from I equals 1 to 5, because I'm running from 1 to 5 in the numerator position, but I'm going to evaluate my function f at I over 10. And that'll let me run through the numbers 1/10 through 5/10. So again, it was important not to simplify the fractions here so that we had that common constant denominator of 10. So now I can rewrite this as the sum from I equal 1 to 5 of 2 times, now everywhere I see an x, I'm going to replace the x with the I over 10. So 2 times I over 10 squared plus 1. And then we can simplify a little bit. This is the sum from I equals 1 to 5. I'm going to get a 10 squared is 100 in the denominator, but there's a 2 in the numerator, so 2 over 100 is going to be 50. So this is going to be 1/50th of an I squared plus 1, all in parentheses. And now I can use this summation formula in combination with this summation formula to break this up into more granular pieces. So I'm going to get 1/50th times the sum from I equals 1 to 5 of the I squared, plus, from right here, plus the sum from I equal 1 to 5 of 1. And now I can use my summation formulas. I have 1/50th. I have the sum of the I squareds, and my summation formula for that's right here. N is still equal to 5 like it was in the previous example because the upper bound of summation is a 5. So I'm going to get 5 times 5 plus 1 is 6 times 2 times 5 plus 1 is 11 all over a 6 plus, and then we're going to get the sum from I equal 1 to 5 of 1, but 1 is a constant, so we use this summation formula right here. The sum from I equal 1 to n of a constant is just the constant times n, so n is equal to 5. The constant is equal to 1, so we're going to get a 1 times 5 again, and then we can simplify some things here. So 6 goes into 6 once, and 5 goes into 10 times. So it looks like we're going to get 1 times 1 times 11 over 10 plus 1 times 5 is 5. So we need a common denominator. We'll multiply by 10 over 10. So this is going to give us 11 plus 50 over 10 is going to be 61 over 10.